Good day and welcome to the Math Salon. Today we'll look at an advanced level equation which concerns integration. So the question requires us to evaluate this integral, the integral from 1 to 2, 3 multiplied by the natural log of x raised to the power 2 dx. Excuse me. So this is our question we are supposed to solve. So normally when you have an integration question to do, it's important to check if you have special integrations that are well known, that you can immediately be able to read or make a substitution or do others. If you can find that, then most probably you have to require integration by part. Notice always integration by part question will require possible repetitive functions or functions with powers that have to be reduced. In this case, we have our ln to the power 2, which will have to be reduced in order to get a convenient form, because we easily will be able to know how to solve the others if we get them right down to nothing. That means when I'm choosing factors that I want to use, I have to take that into account. Which of these two pieces am I going to use for what? The integration by part formula indicates that if you have the integral of u, a function u, and the v du, where each of them is a function of x, then we can write it as a product of u and v, the functions themselves, minus the integral of u dv. If that is the case, then you can use this and try to assign your v and your du to the problem at hand, and your left hand side will simplify to something to your right hand side. What will happen is that this part is going to be a much simpler integral, and you do that a number of times until you can actually integrate the last piece, then you stop. The problem now is to be able to remember your integration by parts formula, but for me, usually I don't keep everything in my head. I keep the most important things, for example, like the product rule. So if you have two functions, u and v, to differentiate, this is normally equal to u dv plus v du. If I try to arrange it to look like what I see here, then I'll take v du on this, leave it on this side and take the others the other way, or I swap all around, that doesn't matter. That means v du plus u dv is equal to duv. This can come to this side and I get v du is equal to duv minus u dv. If I take the integral all through, then this is exactly what I have below here. So now my idea is to compare these two and make decisions on what to choose. This 3 is a constant, so I can just keep it outside and solve till the end, and then I bring it in. If I do that, then I have basically this 2 here. So what I will do is I say, okay, I'm going to let this to be equal to v and this to be equal to du. Then this will look like this side of the equation. So you have v du. If I let that v to be equal to this, then of course my right hand side requires that I should be able to differentiate v. So if I choose that, then my dv dx is 2 multiplied by ln x times the derivative of the inner part, ln x, and that is 1 over x. So that means you do your chain rule. The derivative of ln x raised to the power 2 is 2 multiplied by ln x times the derivative of the inner part, which is 1 over x. If I do that, it simplifies to 2x ln x. Then your u then, du, will just be equal to dx. And this means if I integrate both sides of that, then the integral remove the derivative. The integral remove the derivative, and then this gives me that u is equal to x. So now I have all the ingredients I need, and it's just left to prepare the nice and delicious food. So I needed these things, and I have them all. So u and v are known. This is my u, that is v, so I can just substitute inside. So now my left hand side is this with the 3 standing outside. Since I was able to make this to look like this, then I can also use this part of the formula. So this part says multiply u and v. So this is here, my u here, and that is v there. I multiply them. Minus, this is a minus. This integral, it says put u. U is still x. This is x here. So this is u again there. And then what was my dv? dv dx, of course, is a function of x, is 2 on x ln x. and that is 2 on x ln x. If I do that, it's just a matter of simplifying this. If I do simplify that, then I come up with something like 3 multiplied by x in brackets ln x to the power 2 minus 2 integral of ln x dx. I still have another level to go. It's still of the form here. The integral in x is not direct, straightforward. You can do that immediately. So you still have to do another integration by parts. Once again, I will let this one to be v. This is v here, and this one to be du. So v is equal to ln x. dv dx is 1 over x. So we can just put this as well. That du is equal to dx. It's simple. There for you. Then if I take both sides, if I integrate both sides just like before, then I'm going to get u is equal to x. And again, I will do the same thing. You don't forget, make sure. So what I did is I said, okay, copy this integral and call it 2 so that you don't mix everything up. So based on that then, I will say that this my 2 should be written to be done in the same way as before, where this is my v and that is du. So then, this is, the rule says u and v multiply together. V is ln x, u is x, so that is x ln x minus, so this is my u here multiplied by v, minus the integral of, it says write u, this is my u there, and then dv, of course a function of x, that's why the dx is there, is that. So this is my u here, this is my dv here. So if I do that, the x's cancel, and of course the integral of 1, because 1 remains, the integral of 1 is x. So it means this simplifies to x ln x minus x. Of course, remember that I took it from here. It came from here. So I have to go and substitute it back. So I write my original I, this one that was there, 3 was there, this is a 3, x ln x to the power 2, this is it here, minus 2, and this part is replaced with what I just obtained, and that is x ln x minus x. Once this is done, you are left only to substitute the limit. The upper limit inside here, minus the lower limit, and you simplify. Thank you. Do not forget to subscribe and give us some thumbs ups.